Hello everyone. Now we have to discuss the next concept, nodal analysis. Nodal analysis. What is nodal analysis? Before that, what is mesh analysis? Mesh analysis is a method that provides a general procedure for analyzing the electrical circuit using loop currents as circuit variables, right. Here, this is a method that provides a general procedure for analyzing the circuit using node voltages as circuit variables. There loop currents, here node voltages, that is it. Nodal analysis, that is definition. What is the definition here? Nodal analysis is a method that provides a general procedure for what? For analyzing the circuit using node voltages, as circuit variables. That is it. In case of mesh analysis, loop currents are circuit variables, but in case of node analysis, node voltages are circuit variables. So, there mesh analysis is the application of KVL, here nodal analysis is the application of KCL. It is the application of KCL. One more important point, number of nodal equations. So, there in case of mesh analysis we have what? Number of mesh equations, that is equals to B minus n plus 1, number of branches minus number of nodes plus 1. Here n minus 1, that is number of nodes minus 1. Therefore, we have that number of nodal equations are getting. Okay. So, next types of nodes. We have simple node, principal node and single node, right. We have simple node, principal node and single node. So, like that we have non-reference node. What is non-reference node? It is a node which is having a definite voltage in it. So, the node which is having a definite voltage in it, that node is nothing but non-reference node. So, examples are what? Simple node, principal node. Examples are simple node and principal node. So, these are the nodes which are having definite node voltages. Next one is reference node. What is reference node? it acts as reference to all other nodes. It acts as reference to all other nodes. Examples: earth node, earth node. That is, what is this earth node? This is nothing but a reference node. So, what is the meaning of this reference node? It acts as reference to all other nodes. What is that meaning? See, to explain the importance of reference node, here I am considering two examples. So, in these two examples, we are having tank A, tank B. So, tank A is more height than the tank B in this case one. So, this is the ground level. Okay. So, tank A is more height than the tank B. So, we all know that there is a water flow from this tank to this tank, right, because height makes the water flow. So, therefore, there is a water flow from this tank to this tank, no problem. Then coming to this case, with respect to this ground level, this is what ground, no? This is relative height, this is relative height. So, with respect to this ground, we should consider relative height, no? That is why there is a water flow from tank B to, from this tank B to tank A. So, with respect to this ground level, we are considering what? Relative height. So, based upon this relative height, there is a water flow from tank B to tank A. Then you have clear area. So, this is the importance of reference. So, by seeing this, we cannot able to tell what is the exact voltage of different nodes. We cannot able to tell, we cannot judge initial itself. After calculation only, we can able to tell what is the exact voltage of that particular node. Okay. So, based upon this example, we can assume something. So, assumption. What is the assumption? With respect to reference node, with respect to reference node, assume all currents leaving from non-reference node. So, with respect to node voltage, assume all currents leaving from non-reference node. That is, what is the meaning of this? That is, we should consider unknown. We do not know the exact value of node voltage. We cannot able to judge the exact node voltage initial itself. Okay. Consider unknown non-reference node voltage. We should consider unknown non-reference node voltage more than the other voltages. Then only this assumption will exist. Means what? For example, unknown node voltage, for example, V A, right? At this node A, we do not know the voltage, that is unknown node voltage. We have, for example, 10 volts by resistance. So, which is equals to what current? No? This is for example, okay. For example, here say this is unknown node voltage minus some voltage value by resistance. Here we can consider the resistance value, for example 5. So, what is the assumption? We should consider unknown reference non-reference node voltage should be more than the other voltages. If V A is equals to 20, what about current I is equals to positive, right? If V equals to 20 volts, I is equals to what? 20 minus 10 by 5, positive. If VA is equals to 5, I is equals to what? Negative. IA is equals to negative. If it is true, I is equals to positive, right? That is it. If it is negative, if it is false, I is equals to negative. That is it. We can assume the unknown non-reference node voltage should be more than the other voltages, that is all currents leaving from non-reference node. Okay, we should consider like this. We have to assume something, right? So, this is the assumption. If it is true, you can get the positive current, otherwise we can get negative current. There is no problem at all. See the magnitude of current, that is it, you all know that. Okay. Discuss some note points. First one is if a voltage source is present between non-reference and reference node. If a voltage source is present between non-reference and reference node, then the non-reference node value should be the value of voltage source value. If there is a voltage source between non-reference node to reference node, then the corresponding non-reference node voltage should be equal to the voltage source value, that is plus minus this is 20 volts, say, okay, this is 20 volts, this is the node, this is the node, this is what reference node, that is ground node, okay. This is reference node, this is non-reference node. So, here the voltage source which is present between non-reference node and reference node. We have some branch, for example, that is why here I am providing a dotted lines, maybe there is a resistive branch. So, therefore, the corresponding non-reference node voltage should be equals to non-reference node voltage, at this case should be equals to 20 volts, that is it. This is the first point, okay. Second one, reference node can be anywhere in the circuit. Reference node can be anywhere in the circuit. Generally, we should take the reference node at the bottom of the circuit, non-reference nodes at the upper side of the circuit. Do not think that always the reference node should be present at the bottom of the circuit. It should be anywhere in the circuit. Just focus on this point. Okay. Let us discuss the steps to solve a problem by using nodal analysis. Steps to solve a problem. First, Identify the number of nodes. Identify the number of nodes and calculate number of nodal equations. That is it. First, we have to identify the number of nodes from the given circuit and calculate the number of nodal equations by using the formula n minus 1. So, next assign node voltages. We have to assign node voltages with respect to what? With respect to ground voltage or reference node voltage. So, we have to assign the node voltage with respect to ground voltage. Ground means nothing but a reference node voltage, means that is the value of reference node is equal to 0. With respect to this reference node only, we can assign the unknown node voltages, that is non-reference node voltages. Okay. By using KCL, write current balance equations. Solve and calculate the unknown node voltages. That is it. First, we have to identify the number of nodes and calculate the number of nodal equations. Completed. Next, assign node voltages with respect to ground voltage. Then, by using KCL, write the current balance equation. Last, by solving those equations, we will get the node voltages. That is it.